Hey, welcome. Today we're going to be talking about linear and rotational equations for simple harmonic motion for AP Physics C mechanics. And this is more of a summary or a review of the unit and equations you will need to be able to derive on the fly, and it would help if you had them memorized as well. So let's talk through what you need to know to be successful on this test. First of all, we do start with this equation here, and this equation is on your equation sheet, thankfully. So I'm going to use the same labeling system that they use, but just be aware that this oftentimes is translated into A. If you think about it, this would be your maximum displacement from the equilibrium position. So that's also called amplitude, right? So just be aware that that is the case. Now there is an implication over here. This is a truism, so that's not very helpful, but I'm going to show you something in a very similar pattern for other equations that we derive. So you'll get the idea in a moment. And I do just want to stress that you can see these equations with slightly different forms where x max is subbed out as A. I use x max simply because your equation sheet uses that, as to not confuse anyone. Alright, so if you take the derivative of this equation with respect to time, what's going to happen is you end up with this equation over here. I've done a screencast on that as well, so if you want more information about that, I'll put a link to that in the upper right about now. And what does this imply? Well, check this out. The sign of anything that is inside here, the maximum and minimum values that you can end up with that would be ranging between a positive 1 and a negative 1. So if you have a range of positive 1 and negative 1 for the sign of some function right here, then that would imply the maximum value we could get for the velocity with respect to time would be just this coefficient out in front here. So that's what we're saying. Our maximum speed, let's call it in this case, is going to be equal to the maximum position or amplitude times omega. Alright, and similarly what we're going to do is if we take this equation right here and take its derivative with respect to time, you end up with this equation here. And in a similar way, can you guess what our maximum acceleration is going to be? This is actually really important. Based on this equation here, what's our maximum acceleration going to be for an object in simple harmonic motion? Alright, well hopefully you're able to come up with the idea that this is going to be equal to our maximum acceleration. That's what it implies because again, this whole thing can range from positive 1 to negative 1, and so the magnitude of our acceleration here will be equal to this. Alright, so those are linear equations you're going to need to be able to derive and or memorize. But what we're going to do is take a look at the rotational versions of these equations. There are rotational versions of these equations as well. And all we're going to do is take these linear variables here and sub out into their rotational version. So let's go ahead and take a look at that. Oh, one thing I do want to mention is that for these equations below, you need to be very careful to use radians throughout. So let me show you what I'm talking about. Notice in this equation here, we've subbed out our x for the rotational version of position. So this is going to be angular position here, and this x gets subbed out for theta max over here as well. So you can see where this is going over here. Again, we have another truism. Basically, theta max is equal to theta max. You could argue that's not very helpful. I agree, but it follows the pattern, and the pattern is helpful. So let's continue with that. You take the derivative of this equation, or easier, you just say what's the rotational version of this equation over here, rotational version of this variable right here and this variable. What do you think? Alright, well this is what it's going to be. So omega with respect to time is equal to, instead of x max, we've got theta max over here times omega. And what does that imply? What's our maximum angular frequency going to be in this case? What do you think we're going to have over here? Well, hopefully you're able to come up with our omega max is equal to theta max times omega. And lastly, we've got the angular acceleration version of this equation right here. So if you would, try to anticipate what this equation is going to look like down below. And so this is what it's going to look like. And again, please try to anticipate what the maximum angular acceleration is going to be for this whole equation right here. And this is what we're going to have off to the right. So hopefully that's been helpful. Hopefully you're reviewing and getting ready for your exam. And if you have any comments down below, please let me know. Have a great day.